you already understand the basic concept of computer network and the internet in Chapter 1, and now can differentiate its major component that builds up the operation. Now we are going to learn more details on the application layer, which is an abstraction layer that specifies the shared protocols and interface methods used by hosts in the communication networks. Do you still remember the 7 OSI layer in Chapter 1? The application layer is the last layer after the presentation layer and is the closest to the end user. In other words, both the OSI application layer and the user interact directly with the software application. This chapter contains the conceptual and implementation aspect of network applications. We'll begin by defining the key application layer concepts, including network services by applications, clients and servers, processors and transport layer interfaces. We will also examine several network applications in details, including web, email, DNS, and P2P file distribution. This is the outline of Chapter 2. For this video, we will be focusing on the principles of network application. The information about the rest of the topics can be found in the supporting materials for this chapter. So happy learning and enjoy the video. Before we start, let's take a quick look on some of the common network applications that are trending nowadays. Since the internet inception, numerous useful and entertaining applications have indeed been created. These applications have been the driving force behind the internet success, motivating people in homes, schools, government, and business to make internet an integral part of their daily activities. Some of the internet applications include the classic text-based applications that are becoming popular in the 70s and 90s are email, text messaging, remote login, and the killer apps in the 90s, which is the World Wide Web, which include web surfing, search, and also electronic commerce. It also includes the peer-to-peer file sharing and instant messaging. Since early 2000, we have also seen an explosion of popular voice and video applications, including voice over IP and also video conferencing, such as Skype, and also real-time video conferencing. We have also seen some user-generated video distribution such as YouTube and Netflix. And most recently, we have seen the emergence of new generation social networking applications such as Facebook and Twitter, which have created engaging human networks on top of the internet networks. We have seen such interesting and killer apps that have been developed over the years. Perhaps some of you might also generate the next generation killer applications. But before you develop any new apps, there are some important characteristics that you need to know. First, you need to write a software that can run on different multiple end systems. This software could be written in any programming language such as C, Java, or Python. You must also make sure that the application can communicate with each other over the network. When developing such applications, you don't have to write a software that runs on network core devices such as routers or switches. Even if you wanted to write into these network core devices, you won't be able to do so. This is because these devices do not run user applications. They only functions on the lower layers, which are network layer and below. Now, before you start coding your new network application software, you should have a broad architecture plan for the application that you want to develop. Bear in mind that this is distinctive from the network architecture. The application architecture illustrates how the application is structured. There are two possible structures which are client and server, and also peer-to-peer, or also often known as P2P. Okay, let's start with the client and server architecture. The figure shows its architecture, where one end system is called client and the other is called server. Client is any end system or host that initiates the communication process with the server. A typical example is the web application, which have an always-on web server, which service requests from browsers running on client hosts. Note that in this architecture, clients do not communicate directly with each other. Instead, they communicate through the server. For example, in the web application, two browsers do not directly communicate. Another characteristic of client is that it may be intermittently connected and have a dynamic IP address. Some of the well-known applications that are using client and server model are FTP, Telnet, and email. The server, on the other hand, is an always-on host that waits to be contacted by the client. The server will receive requests from clients and respond to the client's requests. They are also made to have a fixed, permanent IP address so that they can be always contacted by the client. Normally, a single server is incapable of keeping up with all the requests from the clients. They can easily become overwhelmed if it has only one server that has to handle all the requests. For this reason, a data center which can handle large number of hosts often used to create a powerful server. Among the most popular one is search engines such as Google, Internet commerce such as Amazon and eBay, Gmail, and social networking live such as Facebook and Twitter. Now, let's move to a peer-to-peer architecture. In this model, the end host that wants to communicate with each other is called peer. If you are planning to adopt this architecture, you have to keep in mind that there is no always-on server. As its name implies, in this architecture, all end hosts such as laptops and desktops communicate directly with each other without going through the server. Most of these peers are residing in homes, universities, and offices. Some examples of the applications are file sharing, Skype, and Internet television, the IPTV. Some other applications may have also adopted the hybrid architecture by combining both the client-server and the P2P elements. In this case, peers request services from other peers and provide services in return to others. One of the most compelling features of P2P is self-scalability, whereby each peer may also add service capacity to the system by distributing files to others. It is also cost-effective since they don't involve server infrastructure and bandwidth to be installed. Before building your network applications, you also need a basic understanding of how the programs running in multiple end systems communicate with each other. In the networking jargon, it is not actually the programs, but the processes that communicate or talk with each other. Therefore, a process can be thought of as a program that is running within the end system. When processes are running within the same end host or end system, two processes communicate with each other using inter-process communication defined by the operating system. On the other hand, processes in different hosts communicate by exchanging messages. A sending process creates and sends messages into the network. A receiving process receives these messages and possibly responds by sending the message back. Now we know that the two processes communicate with each other by exchanging messages. Any message sent from one process to another must go through an underlying network. Actually, a process sends message into and receives message from the network through a software interface called a socket. Let's consider an analogy to help us understand this concept of socket. Consider these two houses, one for the sender and the other one is for receiver. Now these houses can be used to assemble the process, while the door of this can be used to assemble the socket. When a process from the sender side wants to send a message to another process on the receiver side, it will push the message out of its socket, which is the door. The message that arrives at the destination host will also pass through the receiving socket. That is about the interface. But have you ever wondered how the message can safely deliver to the correct destination host? In order for a process running on one host to send packets to a process running on another host, the receiving process needs to have an address. To identify the receiving or destination host, two pieces of information needs to be specified. First, the address of the host, and second, the ID that specifies the receiving process in the destination host. In the Internet, the host is identified by its IP address. In addition, to know the address of the host, the sending process must further identify the receiving process which is running on the host. This is because the host might handle more than one processes. Therefore, it would be easier to identify the process using what is called port number. The most common port number is port 80, which is for web server, and port 25 for SMTP. After specifying the IP address and the port number, we assume that there is a transportation infrastructure that will transport the message to the door of the destination process. However, can we guarantee that the message is arrived correctly at the destination without any loss? Packets can be easily lost in the network due to several reasons, such as network congestion and also corrupted bits. For many applications such as email, file transfer, and also financial applications, packet loss cannot be avoided. This can cause devastating effects which can lead to information loss and also unbounded delay where the message cannot be received by the recipients. Therefore, in order to support these kind of applications, reliable data transfer needs to be provided. This will guarantee reliable packet delivery to destination without any loss, and also to make sure correct arrival of the packets. Having said that, it is also worth to mention that some applications can tolerate some amount of loss of between 1 to 2.5%. These are called loss-tolerant applications. Examples of such applications include multimedia applications which are audio and video. The loss of data in these kind of applications might result in just a small glitch that may not be noticeable to the users. Up to this point, we have been considering the reliable data transmission services that a computer network could provide in general. There are also another criteria that should be taken into account in designing any network applications, such as throughput and also timing issues. Similar for reliable transmission, some of the applications can tolerate some amount of delay, but some simply can't afford it. For example, sensitive information transfer such as email and also web document, cannot tolerate any loss, but they can tolerate some delay. In other words, they are not delay sensitive. On the other hand, real-time applications such as internet telephony and also video conferencing can tolerate some amount of delay, but they are somehow delay sensitive, where they can only tolerate up to certain small amount of delay.
So by now you should be able to understand the conceptual and implementation aspect of network applications, HTTP and FTP file transfer. I hope this video is really beneficial for you and can help you improve your understanding about the network applications. So till now, bye!